Hello, this is Mrs. Grizafi. This is our first video lesson. So, as I told you in class, you can either print out the note sheet and then write down the notes, copy them onto there, or if you would prefer, or if you don't have a printer, then you can just copy everything down onto a piece of loose leaf to have in your notes. Also remember to feel free to email me, message me on Remind, or text me through that number that I put on your syllabus, that any questions you have or anything that you think that might help. And we'll kind of get through this together. And I definitely want to hear from you with any and all of your questions. So the notes that we're doing now are 9.06, and this is on geometric mean, our PAP and help notes. So the geometric mean, remember we had talked about a couple classes ago, we talked about the product of the means equals the product of the extremes when you cross multiply. So your extremes are right here on the end, and your means are kind of here in the middle. So the one thing we need to remember about geometric mean is that your means are going to always be the same. It's going to be the same number or the same variable. So a mean proportional is a positive number x such that a over x equals x over b. So when you cross multiply and solve that, you'd get x squared equals a times b. So you would take the square root of each side. But since it's a positive number, we don't have to do the plus or minus. We're only going to take the positive, leaving us with, like you see above, x equals the square root of ab and just the positive value. So for number one, it says find the geometric mean of 12 and 4. So we're going to call that number that we're looking for x. So we're going to take 12 over our geometric mean is x equals x over 4. So we just set up a proportion, making our means the same along that diagonal, and then we're going to cross multiply. So we get 12 times 4 is 48, x times x is x squared. Take the square root of both sides, where normally we would show our plus or minus, or even if you show your plus or minus, reject that negative. And then we always want to put everything in simplest radical form. So we break this into the largest perfect square that goes into 48 is 16 times 3, leaving us with x equals 4, positive 4, add 3 for your answer. Okay, so what I'd like you to do now is go ahead and pause the video and try the second one on your own. So find the geometric mean of 3 and 27. Okay, go ahead and do that right now. Okay, so hopefully you've given that a try when you pause the video. In order to solve this one, you would do the same thing again. So 3 over x equals x over 27. Cross multiply, we'd get x squared equals 81. Take the square root of each side. Again, we don't want that negative, so I'm going to reject it. So we're only going to take that positive 9. Okay, so now we're going to move on and kind of use that geometric mean to find missing part of a triangle. So we are talking about right triangles here. And how you want to identify these types of problems is by looking for a right triangle with an altitude dropped inside of it. So really, kind of messy here, sorry. Really, you're looking for two small right triangles inside of your large right triangle. And seeing that picture on a question, that's what needs to trigger your mind to think what we're going to call PAP and help. I like to say PAP and help. So the first one, and the wording is very confusing. So it says in a right triangle, the altitude is the geometric mean. So that's the one that's going to repeat twice, same number, between the lengths of the segments of the hypotenuse. So here we have, this is our altitude rule. Altitude rule. And that's what we call PAP. P-A-A-P is how we remember that. So what that means is the altitude, we said, is the geometric mean. So the altitude, which is the segment CD right here, that's going to be the geometric mean. So that's going to go repeated along that diagonal of their means. And then it's the geometric mean between the lengths of the segments of the hypotenuse. So we're talking about the large triangle here. So this whole thing is the hypotenuse, which is AB. And I'm talking about just the part. So here's one part is AD, and the other part is DB. So if I fill this out, then we would have AD over DB. So anytime you see this and you're looking for the altitude or you're given the altitude, you want to think your part of your hypotenuse, so we're talking about the large triangle, over your altitude equals your altitude over the other part. Maybe you call it PAOP, P-A-A-O-P, other part of the hypotenuse, meaning these two segments, the gray and the red segments right there. Okay, so let's try one of these. So here I'm giving you the altitude is 4. So since I'm giving you the altitude, I'm thinking PAP is the rule that I want to use. So I'm going to take part of my hypotenuse of the large triangle, so this whole thing. So, and when I say part, I mean from one vertex of the triangle to where the altitude meets that hypotenuse. So that's going to be my 3x minus 22 over my altitude, which is 4, equals my altitude. Remember, the mean should always be the same along this diagonal right here, over the other part. So that's going to be this part over here, which will be just x. And at this point, we're just going to cross multiply. So I get x times 3x minus 22 equals 16. And I'm going to distribute my x in. So I get 3x squared minus 22x equals 16. I see I have an x squared and an x. Anytime I have an x squared and an x, I want to get it equal to 0. So I subtract over my 16. I look for a GCF. I don't see one. So now I'm thinking to myself, I want to use P's and C's to factor this since there's a 3 in front of the x squared. So for my P, I'm going to have the product of my first and last term. So 3 times negative 16 gives me negative 48. My C is my center term, which is negative 22. So to write this out, I'm going to jump over here now. I'm going to do 3x squared blank x minus 16 equals 0. I need two numbers that have a product of negative 48 that combine to negative 22. So if you're having trouble, you could always go to your y1 and type in negative 48 divided by x. That'll list your factors of negative 48 and scroll down through the table until you find two that add to negative 22, which will be negative 24 and positive 2. Next, we're going to group your first two terms and group your last two and factor out your GCF. So here, out of my first set, my GCF is 3x, leaving me with x minus 8. My second set, my GCF is a positive 2. You always take out the sign of whatever the first number is. So if the first number is positive, you take out a positive. If the first number in the set is negative, you take out a negative. So that leaves me with x minus 8 equals 0. My two parentheses are the same. That's good news. I regroup, so I write that one once, and my leftovers in the second set. So essentially what we're doing is factoring out our greatest common factor of x minus 8. Now I've got it factored, so I'm going to draw my line and set each equal to 0, and then solve for x. So I get negative 2/3, and x equals positive 8. Now we want to just go back to the problem and make sure both of those work. It's okay to have x be a negative or a positive number, but it's not okay for the length of a segment to be negative. So if I take this and I substitute in 8, that appears to work. I'd have all positive values. But if I put in a negative 2/3 and for this x right here, then my length of my segment will be negative, which is not okay. So I'm going to reject that one and keep only the 8, which would be my final answer for that question. Okay, so that is our PAP. The next one we're going to talk about is called help. So that's if we're not talking about the altitude. We're not given the altitude and we're not looking for the altitude. So this says the length of each leg of the original right triangle is the geometric mean of the lengths of the hypotenuse and the segment of that hypotenuse closest to the leg. So what this one means is we're going to take, so the geometric mean is one of the legs. So we could either talk about AC, and again, we're talking about the large triangle when we talk about the hypotenuse or the legs. So this one we would take either AC or CB. It would work for both. I'm going to take AC. So AC would be my geometric mean, and it's the geometric mean between the lengths of the hypotenuse, so the entire hypotenuse, which is AB, and P again stands for part, but this time it stands for the part that's closest to that leg. So there are two parts to this hypotenuse, AD and DB. We're asking ourselves, is the gray segment closer to the green side of the triangle, or is the red side closer to the green? And our answer here would be the gray. So that tells us that we would want to put it over AD. And you could have done it for the other side. So, or you could have said AB is still the hypotenuse. We could have used the other side, which is CB, and that would repeat. Over the red one would be closer. If we were talking about CB here, the red side would be closer to that as opposed to the gray side. So that would be DB on that one. So what HLLP stands for is your hypotenuse, and again, always of the largest triangle, over the leg equals that leg, same number again, over the part of the hypotenuse closest to the leg that you're talking about. Okay, so let's give this one a try. So we have a right triangle. Again, as I said before, you want to really start to recognize anytime you see this large right triangle with two small right triangles inside. So a large right triangle with an altitude dropped inside of it. So I'm looking here and I say I don't know my altitude and I'm not looking for the altitude. So that tells me I should be using HLLP. So that tells me I want to take my entire hypotenuse. So 7 plus 13 gives us 20. So 20 over my leg. So I'm looking for this leg over here. So we're going to use X over the part closest to X. So we're saying, is 7 closer to X or is 13 closer to X? In this case, 13 is. So that's what I'm going to put there. Cross multiply, giving me x squared equals 260. Take the square root. Again, we only want positive values, plus this is a geometric mean, so we should be rejecting our negative. And we want it in simplest radical form since it does not say it around. The largest perfect square we can take from 260 is 4 times 65. So our final answer would be positive 2 rad 65. Okay, so how do we decide between PAP and HELP? Which rule do we want to use? So you want to be looking at, is the length of the altitude labeled? Or are you looking for that altitude? If you're looking for the altitude or if you're given the altitude, then you want to use the altitude rule. So if yes, there's an altitude, then you're going to use PAP, which hopefully makes sense because there's 2 A's in that. I don't know if you see for some reason there we go. Okay, so this would be PAP. So your part over altitude equals altitude over part. And if you do not have an altitude and you're not looking for the altitude, then you're going to use HLLP. So your hypotenuse over your leg equals leg over the part closest to that leg on the hypotenuse. All right, so let's go through some examples. I want you to think about which rule it's going to be when we look at it. So for example, in number 5, we might say, are we given the altitude or looking for the altitude? So our altitude's right here. And the answer is yes, we're given it. So that's when I would say, okay, then we want to try using PAP first. So we are going to take part of our 2 parts where they meet, where the altitude meets the hypotenuse. So one part is x over my altitude is 2 rad 6 equals that altitude again, 2 rad 6 over the other part, which is x minus 2. So we're going to go ahead and cross multiply. So I'm going to come over here, x times the quantity x minus 2 equals, and be very careful when you're multiplying the 2 rad 6 together in your calculator. So if you're squaring it, hit enter first, then squared, or you can put them in parentheses is fine too. Just be very, very careful typing that into your calculator. It should give you 24. So don't just trust me for doing it. You guys should have your calculators out right next to you right now. Type it in. Again, pause things as we're going and fill them in. Try doing as much as you can on your own and then checking with me. So now I'm going to just distribute this x, giving me x squared minus 2x equals 24. Again, I see I have an x squared and an x, so I want to get it equal to 0. So I subtract over my 24. This one I have a 1 in front of the x squared, so I can go straight to guess and check. So I'm looking for 2 numbers that multiply to negative 24 and add to negative 2, which is negative 6 and positive 4. Draw my line, show that I'm setting each equal to 0. Important to show that step. And I get x equals 6 and x equals negative 4. And then lastly, just double check, make sure both of those would work. So 6 appears to be just fine, but negative 4, if I sub that in for x, it would give me a negative length. So I want to reject that one. And I'm only going to keep the x equals 6 for that one. Okay, so let's look at number 6. So find the values of A and B. So for this one, looking at your altitude, is it given or are you looking for it? And hopefully you said no, you don't have it, it's not given to you and you're not looking for it. So for this one, I would go to HLLP first. But remember too, there's more than one way often to do these. So you could either choose that you want to use the 48 leg or you could choose the 14 leg. So I would pause the video here, give it a try, and see if you can do it on your own. All right, so hopefully you were able to set it up. So it should have been your hypotenuse 50 over, let's do 14 over 14 equals 14 over the part closest to the 14, which would be A. Okay, so you could start with either of those ways. Then we cross multiply, we get 50A equals 196, and A is 3.92. So you could go from here and you could set up 50 over 48 equals 48 over B to solve for B. Or you could just say, well, at this point, I already know that A is 3.92. So just take my total segment, so segment addition postulate, actually segment subtraction postulate, we take 50 minus 3.92, which gives me 46.08. So B is equal to 46.08 for that one. All right, so again, at this point, we've gone over how to tell which one you should use, whether or not you're given the altitude. So I would pause the video, I'd go through and see if you can do 6, 7, and even 8 on your own, and then check back here to see if you got them right. I'm going to go through them pretty quickly, just showing you the work for them. So again, pause the video here and then come back. Okay, so hopefully you were able to do these on your own. It says SR is 1 more than PS. So I'm going to call PS X, and then SR is going to be X plus 1. PQ should be 2 more than PS. So that's going to be X plus 2. Find PS. So I'm not looking for an altitude, nor am I given the altitude. So I'm going to use my leg rule. The only leg that I have is this one, so I have to use that. So I'm going to take my entire hypotenuse, x plus 1, which would give me 2x plus 1. So my whole hypotenuse is 2x plus 1 over my leg of x plus 2 equals my leg of x plus 2 over the part closest to that, which would be x. Cross multiply, so you've got a lot of foiling that you're going to have to do here. You should have x times 2x plus 1 equals x plus 2 times x plus 2. And you want to FOIL that out. I don't know if that disappeared on yours. So we end up with 2x squared plus x equals, and then if I FOIL that out and combine my like terms, I get 4x plus 4. Continuing to solve, I would get x squared minus 3x minus 4 equals 0. I have a quadratic, so I'm going to factor into x minus 4 and x plus 1. Draw my line, solve. I get x equals -1 and x equals +4. If I substitute the -1 in for x, it would give me negative lengths. So I'm just going to keep the x equals 4. All right, number 7. Here we have the find x, y, and z. So a couple things going on here. We need to find 3 different variables. So first I might say, okay, well, I'm looking for the altitude. So, and I have both of those parts. So I'm going to start with PAP. So I would do 7 over y equals y over 9. That gives me y squared equals 63. Take the square root. The largest perfect square I can take from 63 is 9. So I would get y equals +3 rad 7 because I don't want the negative square root. And that gives me y, but I still need to find x and z. So now for x and z, I'm looking for a leg. So that I'm going to use HLLP. So let's see. Let's start with our whole hypotenuse. 9 and 7 gives me 16. So I'm going to do 16 over one of my leg. Let's do x first. Equals x over the part closest to x. So on the big hypotenuse, which side is closer to x? And that would be your 7. So if you cross multiply, put it into simplest radical form. I'll let you guys do that on your own. I'm just going to give you the final answer of 4 rad 7. And then lastly, we're going to find z, also a leg. So we're going to do HLLP again. Take our whole hypotenuse as 16 over z equals z. Over this time, the part closest to z would be the 9. Cross multiply, reject your negative, you get z equals 12. So those should be your 3 different values for x, y, and z. All right, and lastly, number 8. In right triangle ABC, segment CD is the altitude to the hypotenuse segment AB. So let's get a picture going here as we read this. So I've got right triangle ABC. CD is the altitude, so I know that C must have to go here. So that means these could be A or B, B, A, it doesn't matter at that point. The segments of the hypotenuse, segment AB, so that's your whole hypotenuse, are in a ratio of 1 to 4. So my side looks smaller over here, so I'm going to call that my 1x, and this side my 4x. Remember, whenever you have that ratio, just add an x next to each number. The altitude is 6. Find the 2 segments of the hypotenuse. So you're really just solving. Again, you're asking yourself, are you given the altitude or do you know it? And I'm given it, so that tells me I want to use PAP. So I'm going to take the length of my whole hypotenuse, which is 1x plus 4x, segment addition postulate. And so I have 5x. Oh, I'm sorry. We are not using help here. We're using PAP. You actually, here's the eraser. So you want to use part of your hypotenuse. So actually don't need to add those together at all. We're going to take just your 1x over your altitude, which is 6, equals your altitude over the other part, which is 4x. I always think of it as kind of like a semicircle. It jumps up and then jumps down. Okay, so now we just cross multiply. So I've got 36 equals 4x squared. Divide both sides by 4. You want to always isolate your x squared before you take the square root. So that gives me 9 equals x squared. Again, we can't have that negative because that would give us AD as a negative value, plus it's a geometric mean, which is always positive. Final answer is 3, but we were asked to find the lengths of the segments. So let's say AD is 3, and DB, 3 times 4, would give you 12. So that's the one we want to box up. Always make sure you read those questions. Okay, so your homework will be posted on Google Classroom. So it's actually copied from a textbook. So it asked you to do it on separate paper anyway. So as long as you can see it, use separate paper, take a picture of the homework, and then you're going to post that back on Google Classroom and submit that to me. And then I will give you credit for your homework from there and let you know if I have any comments on that. Okay, again, if you have any questions on how to do this or the process or just questions on the math as well, please just contact me, either email me or text me. All right, thank you and enjoy the rest of your day.